Hey guys, Mr. Yisley here. Just want to continue on with the notes. So we're moving to the section in the notes that is all about absolute value. And so as you probably found when you were looking up this term, if you weren't familiar with it, absolute value deals with distance from zero on the number line. So much like when we measure anything, whether we're measuring the width of a door or how long a wall is or whatever it is that you may be measuring, you're never going to have a negative measurement. And that's really what absolute value means, is that no matter if it's a negative number inside those absolute value signs or a positive number, we're really just looking for the length from zero on the number line. And so that length is always going to be a positive number. So absolute values will always end with positive numbers coming out of them. So I just want to talk about a couple of things real quick. We're going to break this section into two videos because it's going to be a little bit longer than some of the other sections. So let's first talk about the properties of absolute value. The first one we'll talk about is that all absolute values are always greater than or equal to zero. That just simply means that they will never be a negative number. That's really all you got to remember about that, is never negative. And I'm just going to write that on my notes. Never negative. So it could be zero, but it will never end up as a negative. It's always going to be zero or greater. The second thing you want to remember is that the negative version of a number, so negative a, is the same as the positive version of that number when it's in absolute values, because they're always going to come out to the exact same length from zero on the number line. So this just means that negatives are equal to positives inside of absolute values. So negative a is equal to positive a. Number 3 says that a times b in the absolute values is the same as the absolute value of a times the absolute value of b. They're going to work out the exact same way, because again, it doesn't matter if a is -3 and b is +4, and that comes out with -12. When you take the absolute value, you're going to end up with 12. So it's always going to be positive. So this is just dealing with multiplication. And then the last one is dealing with the division. It says that the absolute value of a over it says a over b in the absolute value is equal to the absolute value of a over the absolute value of b. This is dealing with division. Now, an important aspect of this is that b cannot ever be zero. So as you should have learned about in your pre-algebra or algebra prep class, the reason b can never be zero is if your b is zero on the bottom, so your denominator is 0, then that means that you have no solution to this problem, because that is not possible. So b can never be 0, but it doesn't matter if they're both inside the same absolute value or different absolute values, they're going to end up the same. And this is again dealing with division. All right, so those are the properties. Just want to go over those shortly and keep those in mind. So let's talk about now, flipping our notes over to what we actually do when we solve absolute value. So I'm going to break this down as simple as I can as I explain it. So how we solve absolute value equations. Well, first thing we want to do is we want to isolate the absolute value. So if you only have one absolute value in your equation, you want to get it to one side. It doesn't matter if it's on the left or the right, but we need it by itself. It can't have the absolute value of a and then -3 behind that. We got to have it by itself. So there should be no terms outside of the absolute value on that side of the equation. We want only what's inside the absolute value on that side. So we got to do that, and you're going to move things by sometimes division, multiplication, addition, subtraction, as we've learned about previously. Once we've done that, then we need to set up two equations. That's pivotal. There's going to be two equations for absolute values, always. Two equations. So your first equation, you're going to remove the absolute value brackets, and you're going to solve it exactly as it is. So you're going to remove the absolute value brackets and solve it exactly as it is. Your second equation, this one's going to be just slightly different. You're going to remove the absolute value brackets, and then you're going to multiply the entire right side of the equation by -1. All right, so you're going to multiply the entire. So if there's 3 terms on the right side, you're going to multiply them all by -1, which is essentially just going to flip their signs. But we have to do it onto the right side of the equation. We just say the right just to keep it uniform, and we're doing it on the same side every time. Technically, you could do it on the left, but really what we want to do is just create a pattern that every time we come across these, we know, hey, on the second equation, I'm multiplying the entire right side by -1. So we're going to get them out of the absolute value brackets as they are. We're going to multiply the right side by -1 for our second equation. Now, one huge thing I want you to make sure that you know is that absolute value brackets can never be equal to a negative number. Never. So you're never going to have the absolute value of x equals -4. Because no matter what you put in for x, it's always going to come out as positive. So that is not possible. So if you end up with or you see an equation after you've isolated the absolute value that is equal to a negative number, that means it is a no solution. And that's our symbol for no solution. All right, so let's jump in and let's take a look at example A here. So first things first. Do I have absolute value? Yes, I do. Obviously, that's what we're doing here in the notes. Second thing is I need to make sure that I isolate the absolute value. So is the absolute value on one side of the equal sign by itself? I do not see anything else outside of the absolute values on that side of the equation, so we're good there. So second, I'm going to set up my 2 equations. So my first equation, I'm going to remove the absolute value brackets and solve as is. So my first equation is simply x minus 4 equals 6. Let me make sure you can see that. Yep, okay, good. X minus 4 equals 6. My second equation, I'm going to remove the absolute value brackets, and then I'm going to multiply the entire right side by -1. So what I have is x minus 4 equals -1 times 6. So the entire right side, which is only 6 in this case. So I'm going to go ahead and then I'm going to solve both of these equations. So my first equation, I have x minus 4 equals 6. Well, I'm into the to-do, undo stuff that we've been talking about. So if I made my little list out here to the side, there's only one thing to do. What are they doing to x? They are subtracting 4. So I need to add 4. So I'm going to split my equation, add 4 to both sides. Again, you don't have to show that to-do, undo. I'm just going through it just to remind you. So again, those cancel, excuse me. We bring down the x, which is left, and then 6 plus 4 equals 10. So there is my first answer to my equation. Then I've got to do the second one. Well, first I'm going to simplify this -1 times 6. So I've got x minus 4 equals -1 times 6 is -6. Then I'm going to go into my to-do, undo. Well, it's going to be the exact same. They're subtracting 4 from x, so I'm going to add 4. So split my equation, add 4 to both sides, and we end up with x equals -6 plus 4 is -2. Now, with absolute values, we have to make sure that we check both solutions. And the reason we have to check both solutions is that we have to make sure we don't end up with what's called an extraneous solution, which you should have learned about earlier in your vocab. So an extraneous solution means that it may seem like it works, but it doesn't actually. So what I'm going to go in and do is I'm going to plug this number in for x into the original equation here, and I'm going to solve it. So I've got absolute value of 10, putting that in for x, minus 4, end of absolute values, equals 6. Then I'm going to solve. Well, 10 minus 4 in absolute values is 6, still in my absolute value, equals 6. And then I've got the absolute value of 6 is 6, so 6 equals 6. Is that true? Yes, it is. So check that answer works. Then I need to do it for my second equation. So I've got the absolute value of, for x, I'm going to put in -2 minus 4, absolute value equals 6. Now remember, don't ever take the absolute value until you have it down to a single number. So I've got negative 2 minus 4. Well, that is negative 6, and that's still in the absolute value, equals 6. So I've got absolute value of negative 6, which is 6, equals 6. That works as well. So my two answers are x equals 10 and x equals negative 2. So make sure on your assignment that you circle your answers so that I can see them nice and plain. If one of them is incorrect, you'll cross it out. All right, so now let's move on to example B. So we've got the absolute value of 3x plus 1 equals negative 5. What equals negative 5? What does this say? Absolute values, brackets, cannot be equal to a negative number. Well, I have a negative number equal to an absolute value. That is not possible. So as soon as we see that, as long as this absolute value is by itself, which it is, there's nothing outside of the absolute value brackets on that side, right? That means that this is a no solution. And that's all you really have to do, is write that. You can just show the symbol. But again, we can't actually derive that until we get this absolute value isolated by itself. If there was something on that side, we'd have to move it over, and that might change the negative 5 into a positive. And if that happens, then we could proceed forward. But because there's nothing to move across, and the negative 5 is obviously negative, that makes this a no solution. All right, so let's take a look at example C. We've got the absolute value of 3x plus 9, then a minus 10 on that side, all equal to negative 4. All right, well, first things first, I've got to isolate the absolute value. So I see that on the same side as the absolute value, I have a negative 10. So I need to move that across much like we've done before. So I'm going to add 10 to both sides to get it across. All right, well, that's going to cancel that. It's going to leave me with the absolute value of 3x plus 9 on the left side equals negative 4 plus 10 is 6. Now this is what I was just talking about how important it is to make sure you get it isolated first. Because the original equation said that it was equal to negative 4. And a lot of us are going to look at that and say, oh, negative number, no solution. Well, once we moved that like term across and got that absolute value isolated, we actually found that it was equal to a positive number, which it can be. So again, make sure you isolate the variable first. All right, so step 2, we need to create our two equations. Our first equation, we're going to remove absolute value brackets and then solve it as is. So first equation is 3x plus 9 equals 6. I've got that written down. My second equation, remove the absolute value brackets and multiply the entire right side of the equation by negative 1. All right, so that's going to be 3x plus 9 equals negative 1 times 6. So there is my second equation. So now I'm going to go back to my first equation and I'm going to solve it. I should always be into either a two-step or one-step equation at this point. So I'm going to do my to-do and undo list. All right. So first thing I notice is they multiplied by 3. Second thing I notice is they added 9. So reverse and use inverse operations. So instead of adding 9, I'm going to subtract 9. Instead of multiplying by 3, I'm going to divide by 3. So there are my steps right there off to the side. All right, so split my equation. And the great thing is, as well, I mentioned, is when you do the to-do and undo, you've got that for both of your equations. It's going to be the same steps to solve both equations. So first things first, subtract 9 from both sides. So that cancels this. I'm left with 3x on the left side. 6 minus 9 is a negative 3. Step 2, divide by 3, divide by 3. I end up with x equals negative 3 divided by 3 is negative 1. Next step, now I've got to simplify. I'm going to go ahead and multiply negative 1 times 6, get that as simple as possible. So I've got 3x plus 9 equals negative 6. And then my steps to solve are the same. I'm going to first subtract 9 from both sides. And let me go ahead and split my equation to see it easier. When I do that, I'm left with 3x equals negative 6 minus 9 is negative 15. All right, and then next step, divide by 3, and I end up with x equals 15 divided by 3 is 5, negative divided by a positive is a negative. So I end up with x equals negative 5. All right, and then remember, third thing is we've got to check the solutions back in the original absolute value equation. Right, the original absolute value equation. Now, technically, you could go to either one of these. You could put it into the original one they gave us, or you could put it into the simplified one. I like to do the simplified one just because it's one less step. I have to do one less piece of work. So I'm going to plug that into the absolute value of 3 times negative 1 plus 9, that's all in absolute values, equals 6. All right, then I need to solve it. Well, according to PEMDAS, I need to multiply first. All right, so 3 times negative 1 is negative 3 plus 9 equals 6. Then I've got negative 3 plus 9, which is 6. So absolute value of 6 equals 6. And the absolute value of 6 is 6. So 6 equals 6. Boom, check. That worked. And I almost ran myself out of room, but just enough. All right, so then I got to do it for the next one. So we've got negative 5, so I got to plug that in. So absolute value of 3 times negative 5 plus 9, again, these are all in absolute values, equals 6. Well, when I do that, I get absolute value of negative 15 plus 9 equals 6. And then if I do that afterwards, I get negative 15 plus 9, which is the absolute value of negative 6 equals 6. Then I'm going to take the absolute value. Absolute value of negative 6 is 6. So 6 equals 6. Check. Good to go. So it all worked out. So that means both those solutions work. So I'm going to circle both of these so that we know those are both solutions, negative 1 and negative 5. All right, a last example right here that we're going to do on this video. I want you to try it on your own. So pause the video, then check back and see if you got it correct. All right, so step 1 with absolute values, we've got to isolate the absolute value. Well, I see I have a minus 9 on the same side, so I'm going to go ahead and add 9 across. So if I add 9 across, I end up with the absolute value of 3x minus 6, which is equal to negative 3 plus 9 is 6. All right, well, once I've done that, now I can go in and create my two equations. First equation, remove the absolute value brackets, solve exactly as it is. So 3x minus 6 equals 6. Second equation, remove the absolute value brackets, and then multiply the entire right side by negative 1. So 3x minus 6 equals negative 1 times 6. All right, so next I now need to solve these. So figure out what I need to do. Well, I see my x and I'm going to create my to do undo up here. So to do to undo. I see the first thing they did, multiply by 3. Second thing they did, subtract 6. And so I'm going to flip-flop, reverse order, inverse operations. Opposite of subtracting 6 is adding 6. Opposite of multiplying by 3 is dividing by 3. So there we go. Now I've got my steps, so let's go in and let's do it. So split my equation. First thing I'm going to do is I'm going to add 6 to both sides. So when I do that, I have 3x left on the left side and 12 on the right. Then I need to divide by 3. So I'm left with x equals 12 divided by 3 is 4. All right, now I need to do the other side. So first thing I'm going to do is I'm going to simplify this negative 1 times 6. So we've got 3x minus 6 equals negative 6. Now a lot of people say, well, why don't you just go ahead and just change that to a negative 6? Well, I could, but it gets more confusing when there's multiple terms on the right side. So I always write it as negative 1 times all of those terms. And I think that just keeps it straight for when it gets more complicated, which you'll see in the next video. All right, so in first step, once I've got it simplified there, is to add 6 as we did before. So add 6, add 6. Those cancel. I'm left with 3x on the left side. Those cancel. 0 on the right. Divide by 3, divide by 3. So x equals 0 divided by 3 is 0. All right, so there's my two proposed solutions. Now we have got to go back in third step, check them back in the original solution. I'm going to do it into the simplified solution of absolute value of 3x minus 6 equals 6. So here we go, absolute value of 3 times x, which is 4, minus 6 equals 6. Well, first thing I do, multiplication according to PEMDAS. So 3 times 4 is 12. So 12 minus 6, all in absolute value, equals 6. And then 12 minus 6 is 6. So absolute value of 6 equals 6. And then the absolute value of 6 is 6. So 6 equals 6. Kind of crazy how we've ended up with all these 6 numbers. I'm not sure how that worked out. But that worked out, so that is a correct solution. So now I've got to check the other one, which is 0. So I'm going to do that over here to the side where I've got just a little bit more room. So absolute value of 3 times 0. Make sure you can see this. Nope. Oh, let me start over. There we go. Minus 6 equals 6. All right. Well, 3 times 0 is 0. So absolute value of 0 minus 6 equals 6. 0 minus 6 is negative 6, so I've got the absolute value of negative 6 equals 6, and the absolute value of negative 6 is 6. 6 equals 6. That is correct, so both of these terms work. Now, if you were to get one that does not equal itself, so you get like 5 equals 6 or whatever it may be, they're not always going to come out to 6 equals 6 like our examples. That means that solution is an extraneous solution. You cross it out and it is not an answer. Only the other one would be. All right, that's all for these notes. Good luck.